Hello there guys, welcome back to another epic inexorable maths video. We have another video on ratio tests coming at you hard and fast. So this is the D'Alembert ratio test once again as a very quick recap of the last couple of videos. Basically, if the ratio between the n plus 1th term and the nth term in a series like this one is bigger than 1, then the series will diverge. And if it is less than 1, then it will converge. That's the ratio in the limit as n goes to infinity, I should say, not just the general ratio, as n goes to infinity. If you want a stronger explanation of that, then again, go in the playlist. I will also link some, put some stuff in the description for you, links to the previous videos there as well to have a look at. But right now, we're looking at this absolute behemoth, okay? So we want to know whether the sum from n equals 1 to infinity of e to the n times n factorial squared divided by 2n factorial converges or diverges. Now, as always, what method should we use? I know that it says ratio test in the title of the video, but what should we use? Can we use the integral test? No. Why not? Because we don't know how to integrate this. We've got to be able to integrate using the integral test. Otherwise, what's the point? Can we use the p-test? No, it's not in the right form. Can we use the comparison test? No, because what would we compare it to? I mean, what would we compare that to? It would be pretty tough. So no, the ratio test seems pretty sensible. By the way, if you ever see a question that involves factorials, there is a 99% chance that it will be the ratio test, okay? Just bear that in mind. All right, so as always, we need to take the limit as n approaches infinity of the ratio between the two terms. Warning, this could get a little crazy, if I don't say so myself. So we need the limit as n approaches infinity of, okay, the n plus 1th term is going to be, replacing the n's with n plus 1's, we will have e to the n plus 1 times n plus 1 factorial squared divided by 2n plus 1 factorial, okay? You've got to be a bit careful with some of those plus 1's there. Very tempting to put 2n plus 1 without brackets, but it's 2 times n plus 1. It'll end up being 2n plus 2 factorial, okay? And then we divide this, I'm going to put some brackets around this, we divide this by the original thing. So the original thing is, I'm just going to extend this slightly, the original thing is e to the n times n factorial squared divided by 2n factorial. So I know it's a bit crazy, right? Now, again, you've got to be really strong at simplifying very complicated fractions like this. So what do? Well, what I'm going to do is I'm going to float the 2n factorial right up to the top, and I'm going to float the 2 times n plus 1 factorial down here. And what you can do is just look at what I've written once I've written it and just, in your head, think to yourself, does that make sense? Make sure that you're happy with it. Don't just look at it and go, oh, whatever. Make sure you're really happy with it once I've written it. So I've got e to the n plus 1 times n plus 1 factorial squared times 2n factorial, like that, divided by, and I've got 2, I'm going to write this as 2n plus 2 factorial, 2n plus 2 factorial times e to the n times n factorial squared. Okay, so I'm just moving out of the way so you can see that a little bit better. Have a look at that, maybe pause it, just make sure you're really happy with that, because don't just take my word for stuff, make sure that you really understand it so that you can reproduce it in an exam or coursework or whatever you happen to be doing. Okay, right, what's the next thing we can do? So there's a lot of simplifying that we can do here. That's the idea. No one in their right mind would try and actually do the limit like this. You've got to simplify it first. So what do? Well, e to the n plus 1 can be written as e to the n times e to the 1. So this is e to the n times e to the 1. And then we can cancel out the e to the n with the one that's down here. Okay, so that's nice. That's kind of already gone. What else can we do? Well, let's have a look. what do we have? Well, we have e, we have n plus 1 factorial squared. I'm noticing that on the denominator, we just have an n factorial squared. So let's just, okay, the rearranging is not that simple, but hopefully it makes sense. If I just forget about the squared for a second, I'm just going to write n plus 1 factorial as n plus 1 times n factorial. Okay, so very similar to in the last video again. So I'm going to go n plus 1 times n factorial, and then that's getting squared. Okay, so that's this term here. We're going to come back to that. And then we still have 2n factorial, just chilling out there. Okay, I'm just going to get rid of that a little bit. Okay, cool. All right, and then what do we have on the denominator? Well, guys, 2n plus 2 factorial, I'm interested in seeing if I can cancel it out with this 2n factorial. But what I have to do there is I have to write 2n plus 2 factorial as 2n plus 2 times 2n plus 1 times 2n times 2n minus 1. But those terms, I'm just going to write that as 2n factorial. Okay, so 2n plus 2 times 2n plus 1 times 2n factorial. Okay, and then I have still got n factorial squared. So it still needs a lot of work, but we're kind of getting there. We're kind of getting there. All right, now what I'm going to do is I'm going to expand out this squared bracket on the top. I've got n plus 1 times n factorial. I want to square that. I want to distribute the squared to both terms. So I'm going to write this as the limit, as n approaches infinity, of n, well, I'm going to put the e there first as well, n plus 1 squared times n factorial squared. Okay, and then there's still a 2n factorial there, which we'll simplify that right now actually. Let's just cancel these out right now because we can. So that and that are gone. So the 2n factorials, they're gone, just to keep it nice and clean here. Okay, and that's it. So then the denominator is just 2n plus 2, 2n plus 1, n factorial squared. So we've got 2n plus 2 times 2n plus 1 times n factorial squared. And now the n factorial squared can cancel out. So boom, boom. Okay, now it's looking really not too bad. Let me just move on to another whiteboard or blackboard, just to, you know, not run out of space. So this is the limit as n approaches infinity of, and then what can we do here? So I would say, let's just expand stuff out now. Let's just expand stuff out. So we still have the e, and then I have n plus 1 squared. So n plus 1 squared is n squared plus 2n plus 1. And then down here, I've got 2n plus 2 times 2n plus 1. That would be 4n squared plus, I would have 2n plus 4n, so plus 6n, plus 2. Hopefully that makes sense where I'm getting all of that from. Okay, just so you can see that. And this is looking pretty good now, right? I know it's a long question, but it's kind of fun. I think so. Okay, what can we do now? Well, I would probably just, you can either take the e out of the whole thing, or maybe I would just kind of leave it in, but just expand the top out one more time. So I've got e times n squared plus 2en plus e divided by 4n squared plus 6n plus 2, like that. Okay, cool. Now, there's several ways, there's two main ways of doing this. Either, and it depends how, it depends on what you need to do in your exam, or how much you want to be satisfied that this definitely is, what I'm about to say is definitely right and definitely works. But some people know that this limit would end up being e over 4, because in the limit as n approaches infinity, okay, the ratio between two polynomials of the same order, so an n, this is a factorial and a factorial, factorial, is just the ratio between the coefficient of the highest power of the variable, so n squared, coefficient of n squared is e, coefficient of n squared is 4, it ends up being that. The explanation behind why I'm saying that some people are happy with just saying this is just e over 4 is because as n gets bigger and bigger and bigger, the 2en plus e and the 6n plus 2 become less relevant, because when n is very big, the thing that dominates it is n squared. So they say, well, it approaches e over 4 because we can ignore the other terms. That's fine. If you're not happy with that and you want a slightly nicer explanation, I'm going to give it to you. We just use L'Hopital's rule, which is probably the thing that you have already thought of doing. And it's that simple. So the limit as n approaches infinity of, and just using L'Hopital's rule, if you're not happy with L'Hopital's rule, I haven't actually got a video on it, but maybe I'll make one and leave it in the description, who knows. Hopefully you are happy with L'Hopital's rule. And the way that you do that is basically, if you're trying to evaluate a limit, if you have infinity divided by infinity, or 0 divided by 0, which we do, we have infinity divided by infinity here, then you can just differentiate the numerator, differentiate the denominator, and then just try to evaluate it again. It's pretty cool. So let's differentiate the numerator. We would get 2en plus 2e. And let's differentiate the denominator. We would have 8n plus 6. This is still infinity divided by infinity. So we would just differentiate it again, or differentiate the numerator and denominator again, use L'Hopital's rule a second time, and that would give us 2e over 8. And of course, we can ignore the absolute value. This is all positive anyway. We could have ignored the absolute values like 10 minutes ago, but it doesn't matter. This is the limit as n approaches infinity of just 2e over 8. But obviously 2e over 8 is a constant, so the limit doesn't do anything, so it's just 2e over 8, which can also be written as e over 4. Now remember, e is the number 2.71, etc. Dividing it by 4, that's definitely a number less than 1. So this is less than 1. What does that mean? Does it mean that the original series converges or diverges? It means that it converges. So this series converges. This is a convergent series, which means that it's equal to a finite number. Who knows what it is? We didn't work it out. It would be very complicated, probably not even a nice number, but this is convergent, not divergent. And that's the idea. So there's the working out there if you want to see it one more time. I'm just going to move the whiteboard up, or the blackboard. I don't see color. And there is, it's actually a green board, but whatever. Yeah. Anyway, there's the working out, guys. I will see you in the next video. Thank you so much for watching, as always. And yeah, I'll see you then. Cheers.